comes in. So on Saturday, you have two things due. You have section 4.4, which is the applications we talked about yesterday. And then you also have the review for exam 2 due. Again, it counts as homework. Due on Sunday by that 11:59 is exam 2, which is over chapters 3 and 4. Don't forget, you're supposed to scan and email that work for partial credit. If you don't send me the work, I will not give you partial credit. You get the grade that you earn. So you want the partial credit. And you also need your replies into that module 2 discussion. So, and then again, if you haven't scheduled to proctor you need to do it now. I sent an email out also. Sorry, that's my job apparently, is just to nag you guys to get this stuff done. So what we're going to do today is focus on actually reviewing for that exam. So we're going to work through some examples. You have additional examples in that review, but this way I'm walking you through what we're going to do. So it covers chapters 3 and 4. That's all the function stuff that was in chapter 3, and then the lines and quadratics that are in chapter 4. It's got the same 13 questions again, and you'll have the 60 minutes to complete it, just like you did on the first exam. So what I want to start off doing, where'd it go? I just had it, and I just lost it apparently. There it is. Sorry. Let's go back. This goes way back. So what I want to do, so our first question is we want to find the domain of each function. And f of x is equal to, our first example is going to be 3x plus 1 over x squared minus x minus 6. So our function is 3x plus 1 over x squared minus x minus 6. This is what we call a rational function because you can see x in the denominator. Okay, how do I go about finding the domain of this? And this is where we need a lot of feedback today. What are we going to do to find the domain?
Set it equal to 0.
Yeah, so set the denominator specifically equal to 0.
Right.
Because we can't divide by 0, we're going to set that denominator to 0. I then need to factor that. So what does x squared minus x minus 6 factor into?
Uh, 3 and 2.
Good.
And
there's a 3, there's a 2, there's an x. Okay, what signs do you want on them?
Positive 2, negative 3.
Beautiful. So then x is a negative 2 and x equals 3. And what you're going to recognize is that these are the two numbers we cannot use. So on our number line, we would have an open circle at negative 2 and an open circle at 3. I don't know why I wrote a 0, a 3. So I'll have open, open like this. So then the domain would go from the negative infinity to negative 2. That's that left piece. You also need to remember that piece that's in the middle from negative 2 to 3, and that's the piece that people tend to forget. And then you also need from 3 to infinity. So you have one interval that matches each portion of the graph. So nice. Good job of remembering, because that was a while ago now. Right? So 3 weeks ago. Comments or questions if I give you a rational function, which I will. Okay, then the other type of function that we talked about when we were talking about domains is a radical function. So what if we have f of x is equal to the square root of 4 minus x? And I want to know what numbers we can plug in for x and get a real number back out of it. So does anybody remember what we did with this one?
You square it to remove the radical?
You could, but because you've got this f of x sitting on this side, what would that be as a square, right? So again, what we want to remember is that we need to avoid negatives on the inside, because we need to be able to put it in and get a number back out to be able to graph it. So we're going to take that inside and set it greater than or equal to 0. So, because all we have to avoid are negatives, it's okay if there's a 0 on the inside. So take the inside, set it greater than or equal to 0. And now we're going to go solve this. So if I move the 4, we'll have a negative x is greater than or equal to a negative 4. And then we're going to divide both sides by negative 1. So that will give us that x is, now I have to remember to flip the inequality, less than or equal to a positive 4. And again, we only flipped the inequality because we were dividing by negative. Okay, so what does that do for us? Again, I'm going to go to a number line. It just helps me get an idea of what's going on. Because the inequality has a less than or equal to, we'll make that a closed circle. And we're going to go to the left this time because we need some numbers that are smaller than that. So when it's all said and done, your domain is going to go from negative infinity to 4 with a square bracket. And currently, those are the only types of functions that we've dealt with. So we've had the radicals, and then we've had the rationals. We will add other types of functions in, but for now, everything else that I would give you would have a domain of all real numbers. So if you remember, we had 3 types. The third type was all real numbers. So, nice. Comments or questions about finding domain? Pretty straightforward if you remember what to do. Okay. The next problem I want to look at, I'm going to give you the graph of a function and then ask you all kinds of questions about the function. So this is problem 2. Okay, so we have a point at -2, -1. So that's -2, -1. You have another point over here at 0, -3. Another point at 1, -4. This is -2, -1. Another point over here at 3, 0. A point at 4, 3. And then the last point we're going to use at 5, 0. Okay, and it looks like this. So it comes down and looks something like that. And we will graph these in chapter 5, but for right now, we don't know how to graph them. So this is at -3, this one's at +3, and that's at 5. Okay, so there's a picture. And you'll see something like this on the exam, and I'm simply going to ask all kinds of questions about it. So first of all, I want to know what its domain is. Just a nice, smooth, continuous graph. What's its domain?
Negative infinity to infinity.
Beautiful. You are correct. So the next thing we'll ask is the range. Bottom to top. Range is always bottom to top. So the bottom of our graph is at, those arrows are saying negative infinity. Where's the top of the graph?
4.
Remember, pick up the y value.
Oh, yeah, sorry. I mixed it up.
Okay, and yeah, which is what I do all the time, so unfortunately. And because it's a closed circle up there at 3, we'll put a bracket on that. Okay, the next thing we're going to ask for are the intercepts. So where are the x-intercepts?
Five.
Okay, so there's one at 5, 0, and then there's another one over here at 3, 0. Yep.
But I think this is one of the things that I was kind of getting frustrated with Pearson is that they didn't want it in interval notation, that they just wanted a singular.
I can't not write it as a point.
Yeah, that was frustrating.
Yeah, well, and then that's why I'm going back through those exams and giving you back credit for things like that. Because, yeah, I find that, and I find it really insulting that they don't have you write it this way.
Right.
I do find it weird that they make you put a comma between things like that, but that's okay. Our y-intercept is 0, -3. So regardless of how you write it on the exam, I will go back in and give you credit for what you've written. So as long as it's the right numbers. Okay, so that gives us all our intercepts. Let's see, what about where the function is increasing and where it's decreasing? So where is it an increasing or where is it a decreasing function? Okay, so let's deal with this logically going from left to right. So if we start over here, and again, these are x values only. They are not points, they are only the x values. So on the left side, we're walking uphill, and we're walking uphill all the way until we reach an x value of -2. So it's increasing from negative infinity to -2. Okay, at -2, then we start walking downhill, and we're walking downhill all the way over to an x value of 1. So we're going to do decreasing from -2 to 1. Okay, then at 1, you start walking uphill again, and you're walking uphill all the way to you get the next value of 4. So it's increasing from 1 to 4. And then at 4, it starts to decrease because you're going to walk downhill, and it's decreasing from there on. So that's from 4 to infinity. So all we've listed are x values, and it's the x values of where we're going uphill and downhill. So again, not points. I will not give you credit on that one. Comments or questions about that? Okay, what about symmetry? Does this particular graph have any symmetry?
No.
So none. Okay, part F. Is it even, odd, or neither?
Neither.
Correct. So we'll simple neither to make it easier on ourselves. And then the last thing I'm going to ask are the maximum values and minimum values. So what are the maximum values? So again, we're looking for the peaks to any hill, and you have to be able to go up and come back down to have a peak. And you're after only the y value. So this is one of the places where we use the y value. So let's see, we've got a peak of a hill over here at -1. And we have another peak to a hill over here at 3. Okay. So then what's our minimum value? Where does this thing have a minimum? So again, to have a minimum, you have to actually go through and come back up. So it has to be a true valley.
One
So again, y value?
or -4. Yeah.
And again, what they're going to ask is a maximum value of, and then they're going to say at, and that's where you would list the x value. So the -1 occurred at an x equal to -2. And the other one occurred at an x value of 4. And this is where I'm not happy with the program, but this is what we've got. And then the minimum value of -4 occurred at an x equal to +1. So, okay, this actually represents 2 different problems on the exam. I just crunched them all together so we didn't have to draw 2 different graphs. So, but there are 2 problems where you're given a graph and it's going to ask you some questions, and then it's going to give you another graph and ask you more questions. So, any problem reading a graph of a function? We spent an entire day doing that, and then came back and did it again.
So we have the, so even though 4, 3 is larger, we still have maximum at -2, 1.
Yes,
-1.
because it's any localized mountaintop. So if you think about yourself out hiking, if you reach the top of a mountain, even though there's another mountain, you're still at that point a maximum. So yeah. Now, absolute max would only be the tallest one, but I didn't pick that up, and we don't really use that too much in our class. We did talk about it briefly, but it's not on the exam. It's only going to come back and haunt you guys when you take your calc classes, so we'll do it in that class. Okay, number 3 is average rate of change. So I want to find the average rate of change of, whoops, f of x equals x squared plus, no, x to the 3rd plus 3x. So x cubed plus 3x from 2 to 3. So I want to find the average rate of change of f of x equals x cubed plus 3x from 2 to 3. Okay, what are we supposed to do? What are they asking me to do?
Plugging the 2 into the f of x.
Okay, so let's go find f of 2. So that would be 2 to the third power plus 3 times 2. Well, 2 to the third power is 8. 3 times 2 is 6. So I get a 14. Beautiful. And then also, we'll find f of 3. So that would be 3 to the third power plus 3 times 3. That's a lot of 3s, sorry. 3 to the third power is 27. 3 times 3 is 9. 27 and 9 is 36. Okay, now that I've done that, what do we do next?
Make them into points. So the first one would be 2, 14, and then 3, 36.
Nice. And I strongly recommend you do that. Because now you're going to come in and find the slope. And this way you can pick up your y2s and your y1s. So again, the average rate of change is just the slope. It's the slope of the secant line between 2 points on a curve. So we'll pick up 36 minus 14 all over 3 minus 2. So 36 minus 14 is what, 12? No, 22. 3 minus 2 is 1. So the average rate of change is 22. So to get from the point 2 to the point 3, you're going to go up 22 units and over 1 is what this is saying. So, nice. Good job. Okay, on the exam, this problem actually has like 3 parts to it, and I couldn't take off a part. So you're going to do it several times, but it's the same idea. So same function, just different pairs of points. Okay, and that's our average rate of change. Any problem with that?
Nope.
Yay. Okay, the next one, what I want to do is I want to describe in words. I don't know what number I'm at. I think this is 4 now. Describe in words the transformation. So we're going to do 3 parts to this one. So let's say we have g of x is equal to the absolute value of x minus 2 plus 3. So this takes the graph of the absolute value and shifts it. How does it shift it? So how are we going to move this thing around?
Up 3 to the right 2.
Okay. So we do right 2 and up 3. And as far as I'm concerned, that's all you need. Yep, that's exactly it. So if I were to physically graph it, then I would take that absolute value. I'm going to go to the right 2, up 3, and then draw in the V shape. So, nice. For B on that one, let's do g of x is equal to a negative of x plus 1 squared. So a negative of the quantity x plus 1 squared. So in words, what are we doing this time? So what's that?
One.
Yep, so left 1, beautiful. Thank you. And then what about the negative out in front?
Stretch of -1. And
Reflection on the x-axis.
Yeah, correct. So the negative is going to do a reflection. If there were a number there, then yes, it would be a stretch. But that negative is going to do a reflection, which is what we're after here. So we're going to reflect over the x-axis. So again, if we were to come in and graph this one, then we know we're going to go left 1, and instead of it opening up, we'd open down, and it's a parabola because it's a square. So it would look something like that. Okay, part C. Let's do f of x is equal to 1 over negative x. Okay, so is the negative on the outside like it was in the previous one, or is that negative now on the inside?
Inside?
So this time we're going to reflect over which axis then? So think about this. You want to take your x's and change their sign. So you're going to switch left to right. So yeah, reflect over the y-axis. So this guy normally would be in this quadrant and quadrant 1 and quadrant 3. So if I pick quadrant 1 up and flip it over the y-axis, it's going to be over here. And if I flip quadrant 3 over the y-axis, it's going to be over here. So it's going to look something like that. Yep. Looks like you've got it. Those are the reflections. So there's 2 different problems on the reflections. One of them actually gives you a shape and asks you to move it physically on a grid. The other ones are asking you to, multiple choice, pick out which ones in terms of words. So you'll have both of them. You'll have to graph it or you'll use words. So, pretty straightforward. You guys tend to like those. Okay. Oh, piecewise function. Okay, so we're given that h of x is equal to 2x plus 1. That's if x is less than or equal to 2. And it's equal to x squared if x is greater than 2. Okay. So what they're going to want us to do is to sketch the graph. So we're going to graph. We want to find the intercepts, the domain and range, and then we want to know whether or not it's continuous. Okay. So those are all the different things we need to do. So when we did these, we talked about the boundary value where it changes from one piece to the second piece. So our boundary value this time is 2, so we know it's going to switch between the pieces at 2. And again, we have a left side and a right side. So this is going to be our left. This will be our right side. In terms of what they're going to look like, what is that left side going to look like? So in other words, when I have y equal 2x plus 1, what does it graph as? Is it a curve? Is it a line? Yep, it's a line. And you know that because it has no exponents whatsoever. What about x squared? What kind of shape is that again?
A parabola.
Yeah, that's our U shape. We'll just draw a little U. Okay. So I'm going to come and draw the left side. That's y equals 2x plus 1. And again, the boundary number or boundary value is at x equal 2. And again, you need to get in the habit of plugging that into both pieces. So I'm going to plug 2 in. For this particular piece, is it an open or a closed circle at the 2?
Closed.
And that's because of the inequality says less than. Okay, if I plug into 2 times 2 plus 1 is 5. But to graph a line, I need 2 points. So we need to pick another value to use. And the key is you need to go to the left of 2. So what other number would you like to plug in?
0.
0 is good. So 2 times 0 is 0 plus 1 is 1. Okay. So I'm going to go graph that. So we have 1, 2, 3, 5, 1, and then 0, we have 1. And again, I need to remember to start at the boundary and go to the left. So it's going to look like that. So there's our line, just like we said it should be. Beautiful. Okay, now we'll come in and do the right side. And that was y equal x squared. And again, the boundary value is 2. So the very first thing I'm going to plug into my table is 2. But on that second piece on the right side, is it open or closed? So this comes back to the inequality. So open. Okay, 2 squared is 4. I need some more values. We're going to pick to the right. So I'm going to do 3 squared, which is 9. I can do 4 squared and get 16, but it's really hard to graph 16. So, okay. And remember, we know it's a U shape. So, sorry, I need to give myself a little more room. I'm only going to go up to 9. 5, 6, 7, 8. Okay. So at 2, we're at 4, and it's an open circle. At 3, we're up at 9. So whatever you do, make sure it's part of a curve. So I'm going to make it look curved. And there it is. Okay, there's our picture. It's a nice picture. Comments or questions about drawing the picture? Again, when you're done, make sure it is still a function. It should pass the vertical line test. So, okay, let's go find the information. What's our domain?
Negative infinity to infinity.
Fantastic. Yes, all real numbers, negative infinity to infinity. Okay, what about the range, bottom to top?
Same.
Same. Okay, and a comment, because I remember that on the review to date, some of you found domain and ranges of each piece separately. That's not what you're doing. You're doing the overall function together. So all together, from left to right, we're using every number, and from bottom to top, we're using every number. Okay, in terms of intercepts, let's do the y-intercept first because it's the easy one. We know it. It's right there. We can see it. So it's 0, 1. Okay, what about the x-intercept though? We can see one. We know it crosses the axis right there, but the question is where is that? Well, that's part of the left piece. That's back up here with our left piece. Well, to find the y-intercept, I'm sorry, to find the x-intercept, can't we just come in and replace the y with 0? So we're going to set 0 equal to 2x plus 1. So 2x equals a -1 and x is a -1/2. So I can go find it. If I can't tell from my picture, I can definitely go find it. So that would be -1/2, 0. And then the last thing is we want to know whether or not it's continuous. So is it continuous? Can I walk along it without falling off? No, you're right. Right here, I'm going to fall down and then I'm going to hit a hole and fall all the way down. So not continuous. Yay. Okay. Yes. Piecewise function. Only one of them. Multiple parts to it though. Again, I would go graph it before I do anything else with it. Okay, our next problem, we're now going to start tackling the kind of application problems. You're actually going to have 3 application problems on the exam itself because we have done quite a few. So I think I'm at 6. We're going to let P be the point x, y, and it's on the graph of y equal x squared minus 1. What I want to do is I simply want to express the distance from P to the origin as a function of x. So this is from section 3.6 is where this one comes from. So we've got a point that's on the graph of y equals x squared minus 1. And we want to express the distance from P to the origin as a function of x. So again, I think it helps to come in and take an idea of what's going on in terms of a picture. So the graph of y equal x squared minus 1. is a parabola that's been shifted down 1. Notice how we're sneaking those transformations in there again. And it looks something like this. So that's y equal x squared minus 1. What we want to do is we're going to put a point on that parabola. So I'll go for this first quadrant because it's just easier. So here's my point P. It's at x comma y. And what we're after is the distance from there to the origin. So we're after that distance between that given point and the origin. So we know the origin is at 0, 0. So let's just use the distance formula. So that distance is equal to, so I'm going to do x minus 0 plus y minus 0. And each of those gets squared. So I have x minus 0 quantity squared plus y minus 0 quantity squared. So those zeros are somewhat meaningless. We'll take them out of there. We have x squared plus y squared. The only problem is they want me to write it as a function in terms of x. So if I'm writing a function in terms of x, what can I not have inside the radical? The y. So we need to replace y in order to write that function as x only. And luckily for us, we know what y is equal to. So we're just going to go back and take that original equation and plug it in. So I have x squared plus x squared minus 1 squared. Okay, now as far as I'm concerned, you can stop right there. I am positive that they will have you clean that up in order to type it in. So we'll FOIL that out. So when I FOIL that out, I'll get an x to the 4th minus 2x squared plus 1. And then I'll collect like terms. So I've got an x to the 4th. I'll have a minus x squared and a positive 1. So, and that's our function. And that's all we're going to do with it. We don't need to do any more with it. That's it. Any comments or questions about that?
No, I'm okay.
Yay. Okay, and then we're going to move into some newer stuff. Again, I'm just picking the ones that I think you're going to have trouble with. There are others on the exam, and you'll see them when you do the review in MyLab Math. These are just the ones that I think that you may struggle with. So let's come in and graph f of x equals negative x squared plus 8x minus 7. And I need to find the vertex, the intercepts. Let's just find the vertex and intercepts. Vertex and intercepts. So, because if you've got the graph, then you can do the domain and range and the intervals of increasing and decreasing. So this is section 4.3. Okay, how do I find the vertex?
Negative b over 2a.
Yep. So that would be a negative 8 all over 2 times a negative 1. That's 8 divided by 2, which is a positive 4. And then what do I do with that?
Substitute it for x.
So f of 4 is equal to a negative of 4 squared plus 8 times 4 minus 7. Beautiful. And be careful, square before you put the negative in. So it's going to give me a negative 16 plus 32 minus 7. So negative 16 plus 32 is 16. Minus 7 is 9. So. Okay, so we now know that the vertex is at the point 4, 9. Does this particular parabola open up or does it open down?
Opens down.
Yep, and that's that negative out in front telling us that, so we know it opens down. So what that is doing, and the reason to take a look at that is, in my mind, I know that I'm over here at 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, and I'm opening down, then I know that, yes, I'm going to cross the x-axis. So they don't have to have x-intercepts. So I think about whether or not it has them before I go spend time trying to find them. So let's go find the y-intercept because that's quick and easy. What's the y-intercept? If all the x's are
7.
zeros, yeah, positive 7 or a negative 7?
-7, right?
Yeah, negative 7, which is clear down here. So this is a fairly narrow parabola. 1, 2, 3, 4, 5, 6, 7. So, did we get all our signs right every place else? Right, that's 25. No, that's, I can do that. 23 from 32 is 9. Yeah, looks right. Okay, let's combine the x-intercepts. So to get those, we're going to set the function equal to 0. So we'll set negative x squared plus 8x minus 7 equal to 0. The minute you set it equal to 0, you can divide the negative out of there. So that's x squared minus 8x plus 7 equals 0. So now we're looking for factors of 7 that are going to add to 8. So factors of 7 that add to 8 are what? 7 and 1. That's x minus 7 and x minus 1. So that works out nice in terms of factoring. If it didn't factor, I'd have to take it to the quadratic formula to find them. But this one factors. So x equals 7, x equals 1. So our x-intercepts are at 7, 0, and 1, 0. And the nice thing is we can see that those are evenly spaced on either side of 4, right? So if this is our 4, we're going 3 units in this direction for an intercept, and we'll go 3 units in this direction for an intercept. So it gives me my nice parabolic arch to the whole thing. Okay, that's everything we need. We can go ahead and graph it. This side's not going to look as pretty trying to get through those points, but there it is. Beautiful. And all the pieces fit together, which is so nice because we can see them all kind of going together. Okay, any problem finding the domain and range from that picture? Right, so your domain's all real numbers. Your range would be from negative infinity to 9. Comments, questions? Okay, one more and we're going to call it good. Let's do one more application problem. And then we'll give you a brief rundown of what's actually on the exam. So,
For that last one, do you know on Pearson if they'll want to bracket at 4 for the range?
wouldn't it be 9?
Negative infinity to 4 or 9? Yeah, that's, yeah, but yeah, the x is 4.
Bracket. Yes,
Yeah.
correct. Okay. Any other comments with the parabola? And they're probably going to ask you about increasing and decreasing on that one again also. So it would be increasing from negative infinity to 4, and then it's decreasing from 4 to infinity. So it's like there's only 13 of them, but so many of them have multiple parts to them that's what slows us all down. Okay, and the last one I want to do says, a developer wants to enclose a rectangular grassy lot that borders a city street for parking. If the developer has 312 feet of fencing and does not fence the side along the street, what's the largest area that can be enclosed? So we've got 312 feet of fencing. Now see, this one makes sense. Here's my street. I'm going to put in a parking lot. I need to fence off 3 sides, but not the side on the street because that's how people are going to get in and out of it. So to me, this makes sense. Okay, we need the largest area. And again, this is from the section that's due on Saturday, so you may not have done these yet. So I'm going to call this L. I'm going to call this W. So what can you tell me about that 312 feet and how many L's and how many W's we need? So how many W's do I need?
2.
Yep. And how many L's?
1.
And then I'm immediately going to solve it for L because I know where we're headed with this. So 312 minus 2W. And we know that our area is which is length times width. But again, as a function, you can't have two variables floating around, two letters. So we're going to replace that L with the 312 minus 2W. So we have 312 minus 2W times W. So it's a negative 2W squared plus 312W. And then what do? I'm trying to find the maximum area. Max area. The minute I say max in our class, what do we think? That word max is telling me to go do the negative b over 2a. Now that won't be true in your calculus courses, but that is true in this course. So the maximum is negative b over 2a. So that would be a negative 312 divided by 2 times 2. Get all my numbers in there correctly. So that's 312 divided by 4. I need to figure this one out. 1, 2 divided by 4 comes out to be 78. And again, the negatives will disappear. Okay, what does that represent in terms of the problem? So you get a number, but what does that number mean? So think about it from a graphing point of view. The input letter is W. The output function is the area. And because it's got a negative, we know it opens down. So sure enough, we can see that max sitting there. Okay, so that 78 represents the width of this. So we know that in terms of our parking lot, it's only going to be 78 feet wide. But they actually want us to find, I'm going to reread it again, what's the largest area that can be enclosed? So we need to find the area. So to find the area, we'll plug it back in. So that would be negative 2 times 78 squared plus 312 times 78. So let's see, negative 2, 78 squared plus 312. I got, these are bizarre numbers. I wonder where I pulled the problem from. So 12,168, and we're in square feet. So the largest area that we can enclose is going to be a little over 12,000 square feet. So make sure you go do the homework so that you'll have practice on those guys. Any comments or questions about that one?
No.
Yeah. Okay. So a brief rundown. Very brief. Again, once you've done the review, you'll know specifically what kinds of questions. The review is twice as long as the exam on purpose to give you lots of practice. We said that it's got 13 questions. I really want to comment that 3 of those are applications. That's what I really want to talk about. So you'll have one that's from section 3.6. We did one that's where you're writing a function. You'll have one from section 4.1. I did not do one of those because I figure you guys can do those. These are the linear functions. So like the cost of renting a truck is so much plus so much a mile, those kinds of problems. And then we just did one from section 4.4, which is a maximum area problem. And those are the application problems. Okay. That's, like I said, a very brief rundown of it. Any other comments or questions?
Nope, I'm good.
Think of? Okay, looking forward to next week, just as a comment, section 5.1, we're going to split over 2 days. We'll talk about both Monday and Tuesday. You definitely want to make sure, I will try to send out the lecture notes tomorrow for that, because it's a lot of pictures, and I don't want to put all those pictures on the board because they won't be as neat as they are on the handout. So just so you know, make sure you're looking for your lecture notes for Monday and Tuesday of next, well, all of next week actually. So anybody else? Anybody got any comments, questions?
I'm okay.
No.
Okay. Good luck on exam 2, folks. Don't forget to send the work to me, okay?
Okay.
Have a great weekend. Enjoy it.
You too.
Bye-bye.